applying systems, we're going to take a look at how we can use a system to solve a digit problem. Now we have to remember that in a system problem that we have two equations. One of them is always going to be about values. So let's talk about how place value is used to help set up a system. Let's take the number 32 as an example. When we look at the number 32, and if we were to put it in expanded notation, because the 3 is in the 10 spot, we would say 3 times 10 plus 2, and 2 is in the 1 spot. Together, that would give us 32. Expanded notation to what we normally call our notation, numerical notation. This place value will help us to understand how something like xy gets explained. The x is in the 10 spot. So the value of xy as a two-digit number would be 10x plus y. Same thing is true if I reverse the digits. If I reverse the digits and I said yx, that would be 10y plus x. I can apply the same idea of reversing the digits to the number 23. If the number was 23, I would say 2 times 10 plus 3. And then I would be able to see how that works out to be 23. We're going to use this idea of place value to help us to find digits of original numbers. So we look at this problem. The sum of the digits of a two-digit number is 10. Well, again, the number we're going to use as a two-digit number is going to be xy. While we're looking at that, xy, we know that the x is in the 10 spot. The y is in the 1 spot. The value of this happens to be 10x plus y. I'm going to draw a line over here so we can keep in mind what we have going on. So our first equation always comes from the first sentence. The sum of the digits of a two-digit number is 10. Well, since our digits are x and y, and we want to have the sum of the digits, we'd say x plus y equals 10. Now, it talks about then if the digits are reversed. Well, what happens when the digits are reversed? We're talking about yx. Again, the value of yx, because y is now in the tens place, would be 10y plus x. Keep that in mind because these two numerical expressions are going to come in handy in this next part. If the digits are reversed, the new number is 36 less than the original number. Well, the new number happens to be 10y plus x. That is, or equal to, 36 less than the original number, and the original number is 10x plus y. So what we're going to do is we'll take a look at this second equation, and we're going to start out by collecting like terms. So I'm going to first start out by subtracting 10x from both sides, giving me 10y minus 9x equals y minus 36. I'm then going to subtract 1y from both sides. That gives me 9y minus 9x equals negative 36. So now I have my two equations. One equation right here, x plus y equals 10, and my other one, 9y minus 9x equals 36. What I'm going to do is use these two equations to find the digits. Now I have to remember that I have two ways to solve a system. I can either solve by substitution or elimination. Personally, I like elimination. So what I'm going to do is I'm going to slide my equation here over just a tad like that. And I'm going to bring this equation down, but I'm going to use the commutative property of addition to rearrange these two variables. I'm going to put y first, then x equals 10. That way, when I go to add them together, they're lined up. But as you can see, if I was to add them right now, nothing would cancel. So I'm going to multiply this bottom equation here all the way through by 9. And get a new equation. Here now I will have 9y plus 9x equals 90. And on top, I'm going to keep the one I had, 9y minus 9x equals negative 36. When I add these two together, the 9x's, right here, negative 9, positive 9x, will go away. 9y plus 9y gives us 18y. 90 minus 36 It's going to give us 54. And then what we'll do then is to get the y variable by itself by dividing both sides by 18. And y equals 3. So far in our quest for digits, we know that the y equals 3. We need to find out what this x value is. Well, let's take a look here. We know in this equation that x plus 3 equals 10. Therefore, x must equal 7. So if x is 7, then the original number that we're looking for, find the original number, is going to be 73. Hopefully this explains a little bit how to do digit problems and how to set them up. Once you get going, you will start to notice patterns, especially when it talks about the value. You'll see the same pattern, and when reducing, you're always going to be finding that you're going to be reducing and having that the two variables, the y's and the x's, kind of set up very similarly every single time.